Alright, so we are officially recording. So, Brandon, there, your question there for the assignment. The second half of the assignment, well, the first half is based on probability stuff there from last week. You know, red marbles, blue marbles, deck of cards, these kinds of things. And I did receive a question, an email there from somebody there talking about they don't understand the 52 decks, 52 cards in a deck in this whole system. We can get on that. Standard questions there in statistics. So if there's any issues with that, just get a hold of me. We'll do a WebEx. The second half of the assignment, which will be... Good morning, Jesse. The second half of the assignment there, we've kind of already done a little bit. We did that there during test 2 and the middle part of the course there. Just some things there that I'll go over again. And you'll see there that the standard normal curve, what we're talking about there, you remember with your standard deviation and all these kinds of stuff, that'll carry on there today, and we'll kind of combine it there with probability. And it's not too bad, but thank you guys for coming. So my plan is I'm going to do a screen share, and we're going to have a look at the test 2 results. Okay, so good morning there. If you, hi Elena, I hope you guys are doing all right. I haven't missed anything there yet. The plan is we're going to quickly go over test 2 and just show you guys what's going on there. Test 2 marks are posted. Okay. You have to understand I've got assignments, quizzes, labs all coming in through Blackboard. I've got lab partners' names not on the lab report, so then lab reports may come in through email. Wrong, like nutrition assignments are being uploaded, and it's okay. You know what I mean? It's the current system. And normally I would take these paper copy in class, or a test would be done in class, right? But it's kind of mashed potatoes right now. So the marks there for test 2 are posted. Please make sure you have a look at them. If something doesn't look right, email me, okay? I put zeros in for tests or assignments or whatever that I just don't have or can't find. And that's all a zero means. So don't email me in all caps and say, hey, I did the assignment and I got a 0. Just say, hey, Ian, I got a 0 for this assignment. I know I did it. I sent it to your email. Can you please check your email there? And easy peasy. All right. So everything's going all right. Let's go over the test 2 for right now. This is from a student there, did very well, and how I mark these generally is if you got me the right answer, then you got full marks. If you didn't get the right answer and showed me that you were on the right track, then you got part marks. If where this got a whole bunch of people was if you got the wrong answer and didn't show me any work, then I had to take off all marks for that particular question. Okay, and we're just going to go through the there was this data set here, okay, and quite tedious. There's a lot of numbers in there. So calculating the mean, median, the mode, okay, the range and the mid-range, they're all there, okay. For comments, I was pretty flexible, okay. There's lots of things there that you could say. I was just looking for some type of critical analysis, deductive reasoning, okay. Comments on the skewness there, it had a positive skew, okay. And so if you left those blank, I -2, okay, generally speaking, all right. This one here, the answer there was 30, All right. I'm recording this anyway, so y'all can go and have a look at it there afterwards. If there's any issues there, let me know. Okay, because I'm instead of printing off all these, I have 150 of these tests. I mark them all online, and I do my best. I have my paper copy here. If there's any issues there with the marking, just let me know. We'll go and fix it up, lickety split. Okay. The Here we're talking about the systolic blood pressure. Okay, and we were just looking there for the mean, median, mode there for these three, which then set us up there for the 10% trimmed mean. Okay, which was 136.75. And again, I was kind of flexible, but then I really wasn't as far as decimals go. Some of you guys are still rounding, and you can't. All right, generally speaking. So just be careful with your rounding, because on the last page there we'll show you when you had the monstrumental calculations there to find the standard deviation, any little bit of rounding will distort your final answer. So these ones here, we're using grouped, okay, and calculate the mean, median, mode there. The mean there was 25.7. The median there was 25. Okay, location of the median there. Your modal class is 20 to under 30. Okay. I think this one here was using the harmonic mean. I accepted an answer around 10. Okay, there's a couple ways that you guys could do this, and I've seen all of them, and they were all good. So that was all right. The final grade here was 70.05%. Okay. Here we had calculating there the average rate of return. I think that one was 13.79%. Okay. For your dental office here, we were talking about, I think we were talking about latex gloves. The average monthly uses there was $263. And if each pair of latex gloves costs 85 cents, what's the cost? I think that was $223. Okay. Again, if you just showed me the right answer with no work, you got full marks. If you showed me the wrong answer with lots of work, I gave you 1. If you showed me the wrong answer with no work, you know what I mean? I'm bound by the rules of the college there. Oh, sorry, this one here was worth 1, so I would take off a half. Okay, if it was the wrong answer, but there was some work shown. Okay. The assignment 2 that's out there right now, we'll talk about that. I'm trying to go paperless, so you guys don't have to, print off copies or, just if I can save paper in some way, save some trees. That's the whole point of assignment 2. But we'll get there. I'll get to assignment 2 there. We'll probably do that after the lecture. All right. What do we got here? The mean price there for 5 passengers is this. We're looking there for the price of the last 2 tickets. Okay, it's around $376. Finding Q1, Q2, Q3 out of this data. I didn't think it was that bad, and pretty much everybody nailed it. Okay, and the numbers there you're looking for were 84, 86, and 97. Okay, and those were 2 marks each. This one here, you were using the empirical formula there. The mode is the plus 2 mean is equal to 3 median. That's what I was looking for there. And a little comment on skewness. That was 3 marks. For the second last page here, a lot of people there, they missed question A. So I gave you the normal curve, and I was just looking for the standard deviation. The first standard deviation, 34%, 34%, 68%. I was pretty flexible as long as I saw either of those numbers. You have your second standard deviation, your third with the corresponding percentages and their numbers down here. So if you gave me something that had, I saw a mix and matches and all that. And again, I was pretty flexible, but some people there, they just missed that completely, and that was -3. Okay. The answer there was 68%. Answer here between 95% is 307, and then between 99.7 is 200 and 800. That's what we were looking for there. And those numbers there, they corresponded right to the standard deviations. So this is, the majority of people nailed this. Okay, and this is where we're going to be heading into today's class, next week's review. Yeah, so if this was all right, we're going to carry this forward there today. We're also going to do review on this as well, get everyone up to snuff on that. All right, so this is the direction of where we're going there for today's class and the second half of the assignment. Quiz 3 will be all over this stuff, and test 3 again. Okay, so this is our focus right here, the standard normal curve. This is your mean. This is 68% of the data falls between our first deviation. Okay, we have the 95% of our data falls in between 2 standard deviations, and then 97% falls in between 3. Okay, so this is where we're at right now. We're going to get there. Don't worry if it's not 100% or you didn't do so well on this part there. After today, you'll be fine. And I've run this course a number of times there. You'll see that normally we would have an extra week, so there'd be 2 weeks of review, right? And I could give you guys lots of questions. So we lost a week there, though. But after today's class, next week will be completely review, where you guys will just hit me with questions, and I'll organize it there in front of a whiteboard of some kind, and we'll just have some fun. But it shouldn't be too bad, okay? This one here, this was a good one. Majority of people did really well. Here I was looking for the range for both of these. So you take your highest from your lowest, and you get a number. I think 38 and 26. So 38 and 26 takes your highest from your lowest. And there you go. That's what I was looking for there. 1 mark each. Using the range rule of thumb. Okay, using that formula there, let me know the standard deviations or the estimated standard deviations for both of these data sets. And I think it was 9.5 and 6.5. Okay, and then there we have, I asked you guys there to actually calculate the standard deviation. This you will have to carry through. Okay, so this is this page here and this page here are the direction that we're going. Okay, and so have a look at this. Find out where you made your mistake. Okay, and as long as you guys filled this out, even if you had the wrong answers, you still got part marks. Okay, but the standard deviation there for systolic was 13.25. The standard deviation there for diastolic was 9.38. Again, if there's any issues, there might have been a marking mistake, let me know. We'll change that up. No problem at all. All right, so this is where we're at. Again, if you're just joining in, good morning. We're just kind of going over the test. This page right here and this page here, we will definitely be moving forward with these two for sure. Okay, so that'll be the focus there. That's where we're at there today. So if you guys have any questions about that, email me. If there's any marking issues, let me know. If you got a 0 or you got a low mark, I emailed a number of people there, because you know what I mean, there's anomalies all over the place. As I said, I've got tests in my inbox, in my Blackboard. I got nutrition assignments where tests should be. So if there's any issues, let me know, because I think we've got, what, 2 weeks to go. Okay, and yeah, 2 weeks today is your final, and that's it, and we are done. And you guys are doing awesome. Keep going. This stuff here, once you get it, it's cake. It's just a matter of just practicing and getting it. And today's lecture, I hope will just nail this. And by the way, I sent an announcement out. I updated this week's PowerPoint. So if you don't have the updated copy, have a look at it, okay? Because that's where we're going. I hope you guys are doing all right. That's the test there, and that was out of 63 marks. Okay. Again, class average was in the high 70s. You know what I mean? You guys are just doing great. So just keep banging these things out, man. Okay. We've got the assignment 2, which is out right now. That's due next week. I might give an extension of a couple days. You know what I mean? We'll see. We'll see how it all goes. But we've got the assignment 2, which I think is, 8%. We've got quiz 3 going out next week, which is 5%. And then test 3, which is 20%. So we've got 34% of the course still to go. Okay? And that's the direction we're going. So let me know if there's any issues. That's that. How are we doing? We doing okay? I'm going to stop sharing in a second. Aha, very good. Hi, morning, Jade. Morning, Megan. I hope you guys are doing all right. No, you guys are all good. And I am recording, Jade, so you didn't miss nothing. All right. And I'll post this there to YouTube after. The one, it's too early. I can't even count. There's only 6 of you. You guys have any questions? We're okay. You guys are okay. We're going to move forward there with the PowerPoint, okay? And then after we go through the PowerPoint, I think everything should kind of be more clearer. Sure, we can do that, Megan. Yeah, stick around after for sure. And so we'll go through the PowerPoint. Everything should be kind of clearer to some extent, at least clear as mud. And this is what I want. I want different levels of clarity. And this week here, in about an hour, you guys should attain some plateau of some clarity on this stuff. Go home, which you're already at, and practice some of the questions. And then next week, there's no extra information. There's no new stuff. We're just going to come back and we're going to rework this stuff. And you guys will be able to master it there by next week. Bang, quiz 3, test 3, easy peasy, move on. That's where we're at. Okay? I hope you guys are doing all right. I hope the chemistry's going well. I hope the biology, you guys should be knee-deep into a kidney lab by now, I think. So if not, if you haven't handed it in already. So I hope you guys are doing all right. If there's any issues, please let me know. We have time. Okay? In another week and a half, time will be limited. So if there's any issues, you've got to let me know now. Have a look at your marks. If there's any issues, be vigilant on that. Okay? And the weight, I'm going to start kicking in the weighted column, which I haven't really kicked in as of yet, but I will there in the next day or so that I don't kick in the weighted column at the start of the year or the start of the semester, because it just kind of makes your marks look distorted because you don't have any marks at the start of the year, but start of the semester. But now that you guys have marks now, the weighted column, I'm going to kick that in. Okay, so you guys keep tabs on that. I hope you guys are doing well. Any questions, just scream and shut up, Ian. Let's go. Shall we? Good. All right. Just let me get this one here. All right. There's my Z table, and there's that. Good. Perfect. All right. Welcome to the normal distribution, which we've kind of already half covered, which was all part of my plan. Excellent. All right. And the whole point of what we're doing there today is so that we can compare apples and oranges. Y'all have heard the expression, you can't compare apples and oranges, right? Well, today I'm going to show you how you can. Okay? And it's actually quite ingenious. We're going to be talking about there the normal distribution, a little bit of review, and applications of the normal distribution, which just means questions. So, review, we're going to identify distributions as symmetric or skewed. You guys are all over that already, okay? We're going to review and identify the properties of a normal distribution, you know, the bell-shaped Gaussian curve, which we've covered already, right? We're going to find the area under the standard normal distribution. And you guys are already kind of familiar with this. Within the first standard deviation, how much percentage is under that curve? Right? 34 and 34, right? So 68% with your mean in the middle. We'll get there. And then you have we'll get there, all right? So you got your probabilities there, which just means the area under the curve, which you're already kind of familiar with. We're going to find the probabilities for a normal distributed variable by transforming it into a standard normal variable. Here's where we get into the ability there to compare apples and oranges. Many continuous variables has distribution that are bell-shaped. Okay, this is called the Gaussian distribution. Okay, and we're good on that. I'm going to fly through some of these things here. The actual mathematical equation for the normal distribution is this ugly thing. Ugh. Don't worry, we're not doing that. All right, I just wanted to show you there that this is not only very mathematical, very precise, it's very scientific. Okay, and wherever you guys go in your scientific careers, okay, you guys will be using this kind of stuff, whether it's reading it or implementing it through lab and experimental data. Okay, and this is the good stuff. You won't be using this though. All right, so I just wanted to show you how ugly it is on the inside, but we're not going to go there. All right, so here we have the shape and position of the normal distribution curve depends on two parameters, and two parameters only. Okay, each one of these distributions, and you see here that there's two. Okay, there's two bananas that each of them have. Okay, the mean, and actually the median and the mode, but here we're just talking about the mean. It's right in the middle. And see, there's another, like these ones right here, right? Okay, they all have a mean. And see here, they're using population mean. We're going to use sample mean. But here's your mean, and here's your mean, right? And these guys here, apples and oranges. And you'll see there that the average apples eaten by Canadians after 2 o'clock, all right, is a number. Let's say 63 apples. And then the average amount of oranges eaten by Canadians after 2 o'clock, you know what I mean, is 87. Different means, but you'll see there that their spread, their standard deviation, is the same. All right, they look the same. And you could put this one right on top of that one, as I have done right here. All right. Each normally distributed variable has its own normal distribution curve, which depends on the values of the mean and the standard deviation. So when you're comparing apples and oranges, what are you comparing? Well, these curves, there's two parameters that we will deal with, and that's the mean and the standard deviation. And you'll remember, standard deviation is your distance away from the mean. So you remember there, your first standard deviation could be in here, right? And that's 34%, 34%. Your second standard deviation will encompass 95%. Your third standard deviation there will encompass 99.7. We'll get more into these kinds of things there later on, okay? So you'll see here that these guys here, they have different means, but the same standard deviation, okay? Where standard deviation just means spread, right? And the tighter, the smaller the standard deviation, the tighter the data. The bigger the standard deviation, the more spread it is. And you'll see right here. So here we have different means and different standard deviations, right? This one here, the standard deviation is bigger, it's more spread. Here the standard deviation will be smaller, so it's more compact in and around the mean, right? Okay, so a little bit more review. The normal distribution curve is bell-shaped. The mean, median, mode are all equal and located at the center. We're just kind of focusing on the mean right now, okay? All right, but they're all there in the center. It is unimodal, all right? It's not bimodal, all right? There was a bimodal question on the test. I think it was, 127 and 144. Any issues with that, let me know. The curve is symmetrical about the mean, so there's no skewness, all right? It's the same on either side, okay? This is equivalent to saying that the shape is the same on both sides. There you go. So, a bit more review here. The curve is continuous. There are no gaps. There's no holes, all right, which allows us there to find the area under a curve, right? And because the area under the curve is probability. We'll get more into that. The curve never touches the x-axis. Okay, it just goes on forever. Okay, it's what we call an asymptote. Okay, so theoretically, no matter how far in either direction the curve extends, it never meets the x-axis, but does get closer. Okay, and if you're just joining in, don't worry, you haven't missed much. We just kind of went over test 2 a little bit, and we're just going through the PowerPoint right now. And after the PowerPoint there, with a bit of enlightenment, I hope, we'll go and we'll hit the assignment 2 that's out and go over that and any questions. Apologies there, I gave you guys a paper copy, and as I was marking the test 2, just the paper copies there were, with a test, you got 6, 7, 8 pages, right? And just the, I just felt bad that I wasn't providing another mode of opportunity for people to upload, and it was just getting to be the same thing. Do a test, take pictures, upload it. Do a test, take pictures, upload it. So I just changed my mind at the very last second, so I gave you guys the paper copy there for the test, but it has since been updated. It's exactly the same test, but I put it into multiple choice format. Okay, so that you guys could enter this there onto Blackboard. The problem with multiple choice, though, is that there is no room for part marks. Okay, because that's not a multiple choice. It's either right or wrong, and I want you guys to do well in this multiple choice test, or the multiple choice assignment 2. All right, so please have a look at it. Please review it before you upload your answers. And the second half of assignment 2, do not attempt it until you have mastered this week's class. Okay, because it's all in preparation there for quiz 3, and it's ultimately all in preparation there for your test 3. Okay, so there are a little bit of review there. Okay, for your normal distribution, your Gaussian curve. Okay, you guys have seen this there before. Okay, this was a test or a question there on your test. Okay, the total area under the normal distribution curve is equal to 1 or 100%, and we've covered these, right? 68% in here. We've got 95% within your first 2 standard deviations, and then you'll have 99.7 within 3 standard deviations, right? Okay, so that's where we're at. And you'll see there that I put these lines in here, and they correspond to the deviations. Okay, and standard deviation is just a number that tells you how far away a data point is from the mean. That's all it is. Okay? And what we're talking about here is probability. So if here you have this curve on the, I don't know, the number of Snickers bars eaten by people over 40 in the suburbs of Toronto. I don't know, whatever. And if you randomly choose a person from within the first standard deviation, okay, what is your probability going to be? Well, the area under this curve here, all of this in here is probability, which is what we covered there last week. You know, you have 4 red marbles in a bag and 6 blue marbles in a bag. Close your eyes. What's your probability of choosing one of the blue marbles? Well, your formula there from probability from last week states, okay, what you're looking for divided by everything, right? That's your probability. And just be careful of odds, though. Odds is kind of the same thing, but it's what you're looking for divided by what you're not looking for, or always in a ratio form. So have a look at that. Any issues with that, let me know. But what I want you guys to understand here now is that the areas under a curve correspond to probability. What chance am I going to get at choosing? Okay, so that's where we're at there. And these numbers here are absolutely relevant. And last week there, we just dealt with, and I think I did this there on the quiz as well, we just dealt with the numbers there that fell easy peasy onto the standard deviations. Okay, and do I still have that test up? Where was it here? Test 2 example. Yeah, and where was it? Right here. So you see, yeah, I think I gave you a mean, okay, and this was your mean, and I gave you, I think, a standard deviation was 100. So if your mean was 500, okay, that means if your standard deviation is 100, okay, the first standard deviation is going to fall on 400 and 600. Okay, all the data will fall between your second deviation will be at 200 and 700, and then within 3 standard deviations, will be 200 and 800. 300 and 700. So there we go. There are your numbers there. Okay, these ones here, I was just doing it there to introduce you guys to the standard deviations there and their corresponding numbers. Today now, where we're going to be at is if I give you a point in here that's not on these easy peasy standard deviation line, how do you find what the probability is for this data point, or this data point, or this data point? It's not too bad. All right. So the standard normal distribution developed there to compare different populations. Here we get into apples and oranges. It's similar to a normal distribution, except that the total area under the standard normal distribution is a value of 1. So here we get back into 100%. This is where we're at, okay? The area under the curve for a particular range of scores is equal to the probability. That's what we're talking about here, okay? So you have a look here. These normal distributions do not necessarily have the same means and standard deviations. And if you have a look here, these are absolutely not true, but the point is hopefully will be well made here. So you have like the number of apples eaten, whatever your study is, okay? And see here you've got a mean of 68. So that's your average, 68 apples per year, whatever, okay? And this one here will have its own standard deviation. You see them there. All right, so you see here, looks like we've got 68% of the data will fall between 59 and 77. Okay, so what's your standard deviation here? Well, here's your mean. Okay, and here's your first standard deviation, so that's what, 9? And then 9 to your next, and 9 so these are real numbers here. Okay, these are the real number of apples eaten. This is a real study. And then over here we have the number of oranges eaten. Well, okay, looks the same. It's got a normal distribution here, but look at this mean. Whew, something's going on here, man. People are going crazy over oranges. All right, so the average amount of oranges eaten is 1,010. And you'll see there we still have the standard deviation lines. All right, so standard deviation there would be 20, right? 1,030 minus 1,010 is 20. And then you see here another 20. So in this case here, our mean is 1,010 and our standard deviation is 20. Well, over here, my mean for apples is 68 with a standard deviation of 9. Whoa, different stuff. How can I compare apples and oranges, man? The means are different. The standard deviations are different. Well, you know what we do? Is we can standardize this, okay, by using what's called a Z-score. And what we can do now, because right now, as it stands, I can't compare. I can't do it. Different means, different standard deviations, eh? Well, then using a little formula, we can transform this guy and or this guy into what's called the standard normal distribution, where the mean is now 0. And here's your first standard deviation in the positive. Here's your first standard deviation in the negative. So right in here, 68% of the data falls in here. It's all the same bananas, all right? And then 95% of your data falls between the first two standard deviations. And you see how it's exactly the same, but what we've done is we've standardized it. So now we're talking deviations away from the mean. So it doesn't matter what your mean is here. I can transform this guy into something that looks like this. And I can transform this guy into something that looks like this. So they both have a mean of 0. Okay? And we can actually compare them now. We'll show you this. We'll show you what's going on. So, and the ability to transform this guy into this or this guy into this, it's easy peasy using Z-scores, and it's all based on there are two commonalities there that we talked about there earlier. Okay, we talked about the same shape, okay, which has to do with standard deviation. Okay, it's unimodal. You see there's one mean. They look like these bell-shaped curves. We can take advantage of that. And also the very fact that each of these has a single mean, we can take advantage of that too. Okay? So, let's move on, shall we? Now, this is the crux of where we're headed. Okay? Utilizing this formula. And if you haven't seen it already, this table. And I'm going to go through all this stuff here, and you guys will be masters at it there within an hour. Okay? So, Z value is just, all it means is the number of standard deviations away from the mean. Okay? And utilizing this formula, okay, which is Z-score, is equal to the value that you're looking at minus the mean, all divided by the standard deviation. So basically what I'm giving you is I'll give you the mean and I'll give you the standard deviation, okay, and I'll also give you the value. You've got to figure out a Z value, and this is the whole thing right here. Okay, so the Z value is the number of standard deviations that a particular X value is away from the mean. It may not mean a whole hill of beans right now, but I'll show you this, okay? And what we're doing here is we're going to take these real data points, the number of apples eaten or the number of oranges eaten, and we're going to transform it into this. Why? So that we can compare. So what do we got here now? And I know that this is going to kind of look like a little bit of mashed potatoes here, but I kind of have like a screen and a half. And I just wanted to show you guys a little example of what we're doing. So this is a 100% completely fake example. I made it up, and hopefully it serves my purpose. It was determined that the average total time spent brushing our teeth was 1,010 hours over the course of our lifetime. Assume the standard deviation is 20 hours. Using the Z-score table provided, okay, this one right here, okay, I want you to convert the following real data points to a standard normal notation. So, ignoring this for right now, it's going to move this right here. Sorry, there's mine. There we go. Good enough. So, you can see there that I just have two normal curves here. And these are real data points that I just chose. Here I have some people there, they spent 1,041 hours brushing their teeth. So you'll see there that there's your mean. And you can see it's the same one there that I use for oranges. All right. But you'll see there's my mean. And you'll see there that 1,041 falls in right in here. Right? And then some people were 977 hours. And that falls right in here somewhere. And some people even spent 957 hours. Not enough time brushing your teeth, I tell you. So, and that's right in here. So these are real data points. And I want you guys to be able to transform these into using Z scores. Now, how do we do this here? I gave you guys an example. So let's try this one right here. Z is equal to the data point minus the mean, and they're just using population mean. This is the mean, all divided by the standard deviation, okay, which I've given you those. So to transform this point, 10,041, I go Z is equal to 10,041 minus the mean, which is given, 1010, all divided by 20. And we get this number. Now, it may look completely nonsensical, but what this number means is that that data point is 1.5 standard deviations away, 1.55 standard deviations away from the mean in a positive sense here. So you'll have a look here that data point, which was right there, because it was 10,041, 10,030, that's right in there, 10,041. And you'll see there that it is 1.55 standard deviations away from the mean. That's where it is, which corresponds to exactly where it was on its original graph, using real numbers. Okay? And that's what that means, that Z is in standard deviations. And if you do the same thing for this data point, the purple one, 977, it would be 977 minus 1010. Okay, 1010 minus 977, which is 3. 3. That is 33.33 divided by 20, and you will see there that you're going to get a negative number, and that's going to be around negative 1.5. I don't have my calculator here, which is very odd. Curses, those kids, eh? They like to use my calculator as a telephone. Here, let me calculate this out here. Calculator. So I've got, we're still doing the purple one here. I go 977 minus 1010, okay, equals and then divided by the standard deviation, divided by 20. So you see here, we got a number. This is for the second point, the purple point. Okay, look, we got a negative number. Well, a negative number tells you it's in the left direction, right? Because your mean is 0, and anything negative is below 0. So this one here is negative 1.65, and you'll see that that point right there, and then negative 1.65, it's right in here. It's exactly the same spot. And if you do the same thing there with the 957 data point, you'll see where that is. That's 1, 2, geez, man, that's almost 3 standard deviations away. It should be anyway. And you'll see there that it actually is. It's negative 2.65. It's right there. So all you're doing using the Z formula is you're taking a real data point and standardizing it. Are you changing anything spatially? No. You're just changing it, standardizing it for the whole point of comparing apples and oranges. And you'll see here that I've got an arrow. Okay? And for this exercise, no, we're not going to go into this, but generally what you're going to be doing here is you're going to be finding the Z-score, and then you're going to look up the corresponding probability on this table, which I show you how to do. But the whole point of this one here was just taking points, real data points, and using Z-scores, you're standardizing them into, you're not really changing it, but now instead of the numbers of apples being eaten or number of oranges being eaten, now you're just distance away from the mean, your standard deviation. Doesn't really change anything. It just gives us the ability there to compare apples and oranges. Hopefully that's okay. We got time. All right. And please stick around after, because we're going to go over the assignment, assignment 2. Okay, and just make sure that y'all are up to snuff with that. We may give you a day or two extension there next week. It's all good. I'm easy peasy. So this is where we're at. All right. What we're going to be doing is, you have a look here. Here's a curve, and here is a Z value, whatever it is. Whatever this standard deviation it is. It could be 1.75. You know, you remember on the last test there, I got you to give me answers there for answers that fell right on the standard deviation. So it was kind of, you know, if you could figure out the standard deviations, then you could figure out these numbers. It wasn't too bad. Where we're going, though, is I'm going to give you data points that fall in the gray areas in here. Okay, how do you figure out the probabilities of data points within that are not on the standard deviation? You have to use Z-score. Okay, so that's where we're at. So here, what I'll do is I'll give you the Z value, and here I'll be looking for the probability of choosing somebody or an orange or whatever you're looking at from in here. Or I could ask you the probability of choosing an apple from in here. Now, what I'm going to try and train you guys to do is guesstimate. Okay? Does your final answer make sense to what you thought? And this is it's a huge deductive reasoning. Okay? You've got to have an answer before you get the answer. Okay? Because calculators can be scary. They can spit out a wrong answer easy peasy. Okay? So this is where we're at right now. If I randomly choose a person or apple from this area, what is my probability of doing so? How do we figure that out? The area under the curve. Okay? Now remember, what is the whole area under the curve? It's 100% or 1. What about just offhand? if I just ignore this for right now, what is the probability of this? Well, this is half. So this whole thing right here is got to be 50% or 0.5. That's easy peasy. All right. This one here, though, so it's going to be 0.5 plus some probability here. That's where we're at. Okay. And so just looking at this, what do you think the probability is? Somewhere 85, 90%, somewhere in there, because that has to be 50. This is 34 plus some. We'll get there. All right. You look at this one here. I could ask you there the probability of choosing an apple from here. Well, now we're into a very small area, right? So we'll get there. Practice is perfect. Look at this one here. I could ask you there, I could give you a Z value and ask you to find me the probability of everything above it. Okay? Well, you're looking at this. This is 50%, so half the question's done. And this is going to be somewhere maybe 35, 40, somewhere percent. So it'll be somewhere around 90%. That's an answer that we're anticipating. And I could ask you there for everything above here. So you could have negative Z, positive Z. You just got to know which side of the mean you're on. You have a look here. This one here, same banana. But I could ask you there for the probability of choosing an apple between this Z value and this Z value. Remember, this standard deviation and this standard deviation. So here, it's not as easy, but it's not too bad again. And again, you could find out the probability of choosing an apple between this amount or this amount. How do you do it? Using your Z-score equation. And I'll show you these. I got more examples than cockroaches. So, you know what I mean? You guys will be just fine. So, after calculating your Z-score, how do you find the area under the curve? So, you have a look here. Did I have it done here? Where was that one? Is that it here? Yeah. So, you have a look here. Z-score, we found a Z-score, I think it was for this one right here, and it was 1.55 standard deviations away. So, getting into this one here, what am I looking at? And I'll zoom in here. These are the Z values you're looking for. Well, not that one. Okay, so, and they go along the side, and they range from 0 up to 3.4. Okay. And you won't need anything other than this table. And it actually goes to 2 decimal places. So what was the Z value there? That was what? 1.55, right? So we would just go down 1.5. Now we want 1.55. So can I get this all on the same screen? Yes, I can. 1.55. I think this is it right here, and it corresponds to here. Sorry, it's being covered up by words, which I'll just move. 1.55. So, 0.4394. Okay? That is the probability. And I'm going to show you how this works. 43.94%. So you see, the information there that I gave you there a couple weeks ago there, the standard deviation, the amount of data that falls within the first standard deviation is 34%, 34%, 68%. And then within the second standard deviation is 95%. And then within the third is 99.7. Well, we can have 1.55 standard deviations away from the mean. We can have negative 2.15 standard deviations away from the mean. And this is where we're talking about, because we can find the probabilities very exactly, actually. So how this works is you'll find a Z value, and then you find the probability, and that's how we're doing this. Okay? So this one here, coupled with the information I gave you, is hugely important. how this table works is it works from the mean out. Okay? It works from the mean out. Okay? So just carry that in your umbrella there for a while, and we'll come back to this one here. All right? You guys know this. The area under the curve is 100%, which is 1. And here we have 50%, 0.5, and 50%, 0.5. Very importante. Okay? So, have a look here. Here we go. Find the area to the left of z is equal to 1.99. So you see here, I'm not interested in converting apples to oranges. Here I've already given you a standardized curve, okay? And I'm asking you to find the probability, find the area to the left of z is equal to 1.99. So you see what I would give you on a test, I'm just going to move all this here, is this right here. That's all you would get for a test. Find the area to the left of z is equal to 1.99. So here's your mean there. There's this value. So I want to know the probability or the area under the curve for all of this. Okay. But remember, okay, this table measures out from here. But you will see that this is... sorry guys, I'm gonna have to pause this. I've got kid troubles. So everyone, please take 5 minutes. I'm gonna stop sharing. I'm gonna stop the recording. Everyone take. We'll see you back here at 9:05. I've got to go take care of something. Okay. Apologies, and yes.